Hello.
Good afternoon.
All right, I hope you all have had a good day today. Getting all your classes in order now. Okay, let's see. Well, let's go through and take the roll. Let's see. Can you guys see me? No. Let's. There we go. Okay. All right. Joran.
Here.
Rachel.
Here.
Alana. Nathan.
He's not here.
Okay. Davin. Davin, sorry. Davin. Chloe.
Here.
Aiden.
Here.
Junior.
Here.
Rhett.
Here.
Price.
Here.
Alan.
Here.
Denon.
Here.
Timmy.
Here.
Matthew. Skylar.
Here.
Hannah.
Here.
Brooke.
She dropped the class.
Okay, thanks. And Joseph.
Here.
And Hannah Zent.
Here.
All right.
Mr. Strong,
Yes.
I'm here.
Who's this?
Alana.
Oh, Alana. Thank you, Alana. Anybody else? Oh, so normally I do read through who is marked absent. So Nathan, Matthew, and Brooke. Okay. Now, so we talked about yesterday about doing the quizzes. So let me just double check and make sure. Now, the thing that I need you to know is that, like, I will be flexible. So, like, let's say that we have set up for you to take a quiz on Friday and you're going to be going out of town. As long as you can work it out with your talent aide to take it at another time, I have no problem with that. Okay? So now I know that, Winslow, they're going to do it right after class. The quiz is right after class on Wednesday. Okay? So we've got that. Okay? All right. So now, so Alan, was Fridays during class time going to work for you?
No, it wouldn't actually.
Okay. So do you want me to set this first one up for Friday, or do you want it like after class tomorrow, or how do you want to do that?
Could we go ahead and try maybe like morning on Friday? Friday morning?
Sure. What time?
Let's see,
And
probably.
make sure that it's okay with your talent aide there.
Okay.
The first hour.
Could we set it for 8:30?
Sure.
Okay, thank you.
8:30 Friday. Now, you'll have a window of an hour.
Yeah.
To do these, but especially this first one will take you less than 5 minutes. Okay? But normally they'll take you about probably 15 to 20 minutes. Okay? Depending on how much like stuff you have to look up in the book. Okay, so let's see now in so St. John's, what did we decide there for you guys?
So our talent not in here right now, but we're all able to come in on Fridays to do it.
For the test?
Okay, so Friday at what time?
See, normally I won't be here in the morning on Friday, but we did discuss to probably stay a little bit after class to do them
On Wednesdays
on
too.
Wednesdays too.
On Wednesdays? Well, do you want me to set this first one up for Wednesday after class? Since it's, I mean, that would probably be the most painless way to do it because this is such a short quiz.
Yeah.
Okay, so we'll say Wednesday after class, and then again, I'll have it open for an hour, but you're not going to need all that.
Okay.
Okay. All right. So then, Price.
Yeah.
What about you?
So I talked with my high school librarian.
Okay.
She said she's willing to do it. She's just wondering if she has to have like any qualifications, like as a teacher
No.
or anything.
No, as long as she's willing to just proctor you, that's
Okay.
fine. Could you give her my email?
Yeah, I will.
And then would you? And what's her name? Do you know?
Forget her first name, but her last name's Baki. It's Miss Baki.
Miss Bahi. Okay. And just so I'll know to look for that. And then, so what about when do you want? When would you like it to be set up for?
The best time would be Thursdays at 8:55.
Okay.
Because I have a free second hour.
Okay. Thursday at 8:55.
Yes. And
Okay.
you said it's an hour-long window, right?
Well, the window will be an hour,
Okay.
but the quiz is not going to take that long,
Okay.
and none of them will. None of them will. The first one will take you less than 5 minutes, and that's taking it twice probably.
Okay. Good.
Okay. All right, and then Moyan, I think everyone was okay Wednesday after school or after class except Joran. Is that? Am I getting?
Before class.
Wednesdays before class.
Oh, Wednesdays before class. So what time?
Yeah. Would be one
So that the hour before class. So
150
Yeah.
to 250.
From 1:50 to 2:50. Okay.
Yeah. And then Joran and Hannah
Anytime from 10
from
to
10 to 11.
any day of the week.
So
Yeah.
Joran and which Hannah?
Whipple.
Hannah Whipple at 10 o'clock to 11. And which, do you want that on Thursday?
Possible.
Let's just keep it Wednesday.
Wednesday? Okay.
Yeah.
Yeah.
Okay. All right. That sounds good. All right. So any other concerns about that? And I totally want feedback on this. Is that if the time or the setup or whatever isn't working for you, just shoot me an email and we'll work on something else. So we'll figure it out. Okay. Okay. Well, let's go ahead and go on to back to one.
Strong.
Yes, please.
Will we get more time for like the chapter tests?
Well, typically the chapter tests, I've always just given an hour on the Moodle, and when I've set in with students as they take it, usually they're done in like the half hour. But you'll have the whole hour. I've now, and as I've asked students to give me feedback on that, I've never had anybody say I've been cramped for time on the test. So what do you think?
Oh no, that sounds good. I was just
Yeah, if here's the deal is that really I think the only issue that you're going to run in with is if you start having to look up everything, then that might be problematic. But if you study for the test and you're doing some practice problems and you're going through and you have your guided notes and your book and everything right there as you're taking the test, and then you just sort of have to look up, maybe that one thing that you forgot or you forgot how to do this problem. Let's look up an example. if that's it, I don't think it's going to be an issue. Okay. But if it is, then I want you to let me know. Okay. So we'll just kind of play it that way. All right. Let's see. Okay. Yeah, let's just kind of see how it goes this first time, and we'll go from there. Okay, so let's switch there. Okay. All right, so we are going to, we just did part 1 on the guided notes from 1.1. So does anyone have any questions so far on anything? Okay. Well, so part 2, we were talking about graphs of functions. So if f is a function with domain D, its graph consists of the points in the Cartesian plane, which are, okay, the input and the output pairs for f. Or you could, another way to write that is of the form x and f of x. Or simpler still, back in pre-algebra, the x and the y. That's the graph for the domain and the range. So you could put any one of those 3 and it would be correct. Okay? Sort of like anyway, just different ways that you could write that answer. All right, so if we want to graph a function, when we first learn how to graph, one of the things we learn is the t-chart. So for a function. So there we pick a value for x, any value that we want. We plug it into the function, and then we get those points. And so then you graph the points. Now, it helps when you're doing the function if you know the basic look of it. So if you know that x squared is a parabola, then that's going to help you. You'll have to graph fewer points if you know what the parent function is. All right, so what I would like you to do is graph this function y equals x plus 2 over this interval. So x equals -3 to x equals 4. So pick some points for x between -3 and 4. Plug it in and figure what the y value is, and then plot those points and connect them. Okay, so your graph should look something like that. So this is a line, and here are some points that you could have in your table. You might have these, you might have other points. That's okay. But there's the basic graph. All right. Okay, now what I would like you to do is see if you can do this in your calculator now. Okay? So what I want is I only want this window from x equals -3 to x equals 4. I want you to graph this line. Okay, so see if you can adjust the window so that it looks like that. Okay, so to type in the function, it's just y equals x, and I use the variable key here, x plus 2. And then to change the window, I want the x min to be -3, and then the x max to be 4. And so then we graph that, and so we get a similar graph there. Okay. Now, if we want the calculator to produce the table, then I do second window is table setup. So here, let's have the first x value be -3. So let's start it at -3. And then let's have it go in increments of 1. So the delta table will be 1. And so then to make the table, I just do second graph, and so then it gives me the table. Okay. All right, so any problems making the table or getting the graph in the calculator? Anybody need any extra help on that? Well, maybe I do. Let's see. Oh, there we go. Okay. All right. Any questions on that so far? Okay. All right, so to find the domain of a function, if the function is listed as ordered pairs, then the domain is what?
All the x values?
All the x values. And then the range would be all the y values. Okay? Now, if the function is listed, if it's just written in functional form, then you use what's called the implied domain. So like we said last time is with domain, the main things you have to look out for are you can't have zeros in the denominator or negatives underneath the radical. So here we have no radical, but the domain would be all real numbers except what would make this go to 0. So that would be all real numbers except -5. Okay. Or here where you have a radical, then you just say whatever's under here has to be greater than or equal to 0. Okay? So whenever you have those are the things that you really have to look out for with domain of a function. Okay? But otherwise with a polynomial, the domain is going to be all real numbers. Okay? All right. Now, when we have a graph and we're trying to look to determine the domain and range from the graph, you look at the x values for the domain and the y values for the range. So like here, this purple graph, the domain is going to be, well, the x's go from -1 to 4. So that's the domain. The y's go from -5 to +4. So that would be the range. So you look at the x's for the domain, the y values for the range. All right, next. Okay, representing a function numerically. The graph consisting of only the points in a table is called a scatter plot or a stat plot. Usually in math it's called a scatter plot, but on your calculator it's called a stat plot. But it's the same thing where you're just plotting the points. Okay? So, for example, let's say in the real world, when you're investigating a phenomenon, you're doing some kind of research. And so in this case, we're looking at tuning fork data, the time and then pressure on the tuning fork. And so here, as you plot you get the data, and here you're plotting time versus pressure, the X and the Y. And then you plot the data, and then what you do is see if you can use your knowledge of functions and math to figure out what's going on here. And here the data seem to follow like a sine wave. So depending on what the data looks like, you might do the line of best fit, the parabola of best fit, the cubic of best fit, or whatever. And I'll show you different ways to do that. Okay? So the first thing that we do is we're going to put the data in as a scatter plot. Okay? So I would like you to put that data in to your calculator and do a stat plot. Okay? Now, if you get stuck, let me know.
I'm stuck. You said on
Okay.
the calculator, right?
Yeah. Oh, you gotta have a graphing calculator. So what you do is you're gonna to put the data in. You're gonna use the stat key. Okay. So you press stat, and then what you're gonna do is edit the lists. Okay. So the first option there is edit. So you press enter for that. Okay. Now your first list, you're gonna put in all the X values. And then your second list, you put in all the Y values. Okay? So go ahead and try that. Go ahead and do that. So here I'm going to have -2, 0, 5, 9, and 10. Okay? And that goes in L1, your list 1. Now, does anyone not show the L1 and L2 in their calculator? Anybody not see an L1 and an L2? Okay. All right, good. So now in the L2, you put all the Y values. So 3, 4, 7. 9, 12. Okay. All right, so everybody have those lists in? Okay, so now to do the stat plot, okay, what you want to do is to turn it on first. So right above the y equals, it'll say stat plot. So to get to that, you do second y equals to get your stat plot. And see where it's turned off? You need to turn that on. So there you can turn it on. Now, you can do some other things with it. You can change what it looks like, the dot, maybe change the color, depending on your calculator. But all of that doesn't matter. You have to have it on, okay? Now, usually when you press graph, you're not going to see it. Or, I forgot to turn off the line that I had in there. So I'm going to go back to the y equals and clear that. But so now when I press graph, I typically am not going to see the stat plot. What you have to do is do zoom stat. Okay, because these values aren't all in the standard viewing window. So if you do zoom 9, that's zoom stat, then it zooms to wherever your data is, whether it's in the tens, hundreds, or thousands. Okay. Okay, so this data then, we're in practice 3 on your paper where it says graph that scatter plot, then what I would want you to do is just do a rough sketch of this on your paper so that you don't have to be perfect. You don't use a ruler or whatever. You're just doing kind of a basic graph so that I can just look and see, okay, you've got the general shape of it. Now, for this, you might remember in algebra when you plotted points, then you would come up with the line of best fit. So the line of best fit, the way that you would do that is, and we're going to do this more later, but if you do go back to the stat menu. Okay, so stat, and then calc, and you get all these different regressions. So the linear regression, that's the same thing as the line of best fit. And then you have the quadratic, cubic, quartic, natural law, there's sine regression, there's a lot of different regressions that we'll learn about later. So if I wanted to do the line of best fit, then I would just go to option 4. And see, then it would calculate the line of the linear regression for this list of data. So on this calculator, you go down to calculate. Some of them you just press enter. And so then it will tell you what the linear regression is. Okay? So again, but it's not always the line of best fit. Sometimes you want the parabola of best fit. That would be a quadratic regression. Or like in the example, the sine wave of best fit, okay? So a sine regression. So you just kind of do whatever your knowledge of the data says, okay, for you to do. All right, and we'll do some more of that. We'll do some more of that later. But as far as just graphing the scatter plot, everybody okay on that? Any questions? Okay. All right, next. So we're back in functions. So if a is in the domain of the function f, then the vertical line x equals a will intersect the graph of f at a single point, a f of a. This is what we call the vertical line test. So if you have a function, a vertical line will only hit it one time. If a vertical line hits the graph more than once, then the graph is not a function. Okay? So, here, if you imagine like a circle, see a vertical line is going to hit that more than once. So a circle is not a function. So when we're studying a circle, usually in the calculator in function mode, usually what we'll do is we break the circle up into its two halves, so two semicircles. Because see now, a vertical line will only hit this top half once and the bottom half once. So these two are functions. So we can study the circle that way. So we have ways to deal with it. All right. So just looking at these, it says, do these graphs represent y as a function of x? So that's our question. So let's start with, start from the bottom here. Okay, Hannah Zent. So what do you think about A here, this first one? Is that a function?
No.
No, it is not, because a vertical line would hit that twice. Okay. All right, Joseph, how about the second one? Let's see, where's St. John's? Okay. Well, let's figure out what happened there. All right. Hannah Whipple. How about the second one?
Yes, it is.
Yes, it is. Okay. And Skylar. How about the third one?
Yes.
Yes, it is. Because even though, like, there's a gap here, that's okay. If a vertical line doesn't hit it at all, that's still good. It's just the vertical line can't hit it more than once. Okay? So good job on that. All right, next, piecewise functions. Sometimes a function is described in pieces or parts, and that's what we call a piecewise function. Now, these are going to become pretty important in chapter 2 as we start analyzing these for limits. So, here's an example of how we take a regular function like y equals the absolute value of x, and we're going to break it up into pieces. Now, you might say, why would we do that? Well, it turns out that the absolute value function it's hard to do calculus on that the way it is. And so if we break it up into piecewise functions, we can do calculus on these pretty easily. Okay? So we're breaking that up. So we have y equals x for x is greater than or equal to 0. So this part, the red part, y equals x. And then y equals negative x for the x's that are negative. So we have y equals negative x. So we took this absolute value function, that was the V shape, and we're breaking it up into the two lines so that we can do calculus on it. Okay? All right. So let's see if you can graph this piecewise function. So this one's actually in 3 pieces. And then this part tells you for what x values you use that graph. Okay? So see if you can kind of piece that together. And I'm going to see if I can figure out what happened to St. John's. Okay, so graphing these functions, that's not the tricky part. At least, I mean, y equals negative x, that's a line. Y equals x squared is a parabola. Y equals 1, that's a constant line, horizontal line. It's dealing with this part over here that can sometimes get a little tricky. Okay? All right, so do you need another minute, or are you ready to see if you got it? Okay. Okay. So let's just see what we've got here. So there's actually going to be the three parts of this graph. So y equals negative x, that's the part along here. That's this line. And so you only see the line actually goes on, you know, the line would go on forever, but you only want the part of it where the x is less than 0. So that means you only want that part of that line. Okay? All right, then from 0 to 1, just this little part right here, then you want y equals x squared. So now y equals x squared, I mean, you only want that part, but y equals x squared is this parabola that goes, you know, forever in both directions. But you want to erase the part that is not between 0 and 1. Okay? And then y equals 1 is this horizontal line. Now, again, it actually goes on forever in both directions. But you only want the part of it where x is greater than 1. So then you get rid of the rest of it. Okay? Now you can put little arrowheads at the end or whatever. But that's kind of how you piece together the different parts of the graph. All right? So, did anybody have that? Or pretty close? Raise your hand if you had it.
Close to.
Pretty close? Okay. All right. Any questions on that? Now, you can use your calculator to help you, but really the problem is that the calculator isn't going to help you know where to erase and what to use. You know, if you use your calculator, it's going to graph like all three, and it's going to look confusing. And so that's why I don't know if the calculator's much help on this at all. You just kind of have to do piece by piece. Okay? All right, next, step functions. The function whose value at any number is the greatest integer, less than or equal to x, is called the greatest integer function. It's found on the calculator at math number 5. So like the greatest integer and 1.5, usually you'll either see it written as 2 sets of brackets or 1 set of brackets. But it means the greatest integer. So kind of as you're going from left to right on the number line, it's like the last integer that you passed. So the greatest integer in 2.3, well, the last integer that you passed is 2. The greatest integer in 1.7 would be 1. The tricky ones are the negatives. So like the greatest integer in negative 1.5, well, from left to right, the last integer that you pass is negative 2. So you can't just lop off the decimal part, okay? You've actually got to think, well, from left to right, what was the last integer, okay? Now, So I mentioned that this is found on the calculator, math, then you arrow over to number, and then option 5, INT is how the calculator uses greatest integer. So if I want the greatest integer in negative 3.6, then that would be negative 4. Okay? So the greatest integer in 2.4 would be what? Well, for the positive,
Two.
go ahead.
2.
2. The greatest integer 1.9 would be 1. The greatest integer in 0 is 0. The greatest integer in negative 1.2 would be negative 2. Let's go ahead and just show them all. The greatest integer in 2. So if it is actually on an integer, it's equal to that. The greatest integer in 0.2 is 0. The greatest integer in negative 0.3 would be what? Negative 1. And then the greatest integer in negative 2 is negative 2. Okay? All right. So now let's see if you can graph the greatest integer function. And then just sort of copy that on your paper. The basic look of it. All right, so Timmy, when you've got it, describe the graph for me.
Yeah, I'm lost.
Okay, so go to your y equals on your calculator. All right, and we didn't ever turn the stat plot off on the last problem. So if where you see that highlighted, that's your stat plot still on. So let's go up there and you can turn it off. This is kind of a shortcut to turn it off. So just deselect it. Okay, so now we want to put in the greatest integer in x. All right, so how do I get that? The greatest integer function, where is that located? In the calculator?
Math number 5.
So math, arrow over to number, and then 5. So that's what it looks like on the calculator. So the greatest integer in x. Close that off. And then you're going to press graph. Okay, now, my window is kind of messed up because of the last stat plot. So now to get it back to regular, I do zoom, standard, zoom 6. And so then that takes me back to the standard viewing window. Okay? So what does that graph look like, Timmy?
It's like a bunch of stairs.
Looks like a bunch of stairs. Okay? So this is an example of what we call a step function. Okay? Because it does look like a staircase. So a step function. All right. Okay, next, increasing and decreasing functions. Says let f be a function defined on an interval I, and let x1 and x2 be any 2 points in I. If the f of x2 is greater than the f of x1, whenever x1 is less than x2, then f is said to be increasing. Okay? That's just a fancy way of saying, look, the y values are getting bigger. Okay? So if the y values are getting bigger, the function's going up. So it's increasing. Okay? If the f of x2 is less than the f of x1, so that means the y values are getting smaller as x is increased, then f is said to be decreasing. So as the x's go on, if the y values are getting smaller, then the function is decreasing. All right, so looking at a graph, if I wanted to know where is this function increasing?
Mr. Strong,
Yes.
could you go back to the site really quickly?
Sure.
Okay, thank you.
So here, if I want to know where is this function increasing, so what I want is the x values, the interval where it's going up. So here, in just this little region right here, the function is going up. So that would be from x equals 0 to x equals 1. So you would say it's increasing, it's decreasing from -2 to 0, and then increasing from 0 to 1. And then from 1 to 3, from x equals 1 to x equals 3, then it's constant. That means it's neither increasing nor decreasing. Okay, just to finish this idea here, let's see if you understand what we're talking about here. So it says, draw the graph of a function that is increasing from -infinity to 1 and then decreasing from 1 to infinity. So there's not just one answer. You graph your own function. All right. So any of these, your graph could look like any of those, or maybe something different. So as long as from 0 to 1, the function's going down, or it's going up, from 0 to 1, for -infinity to 1, and then from 1 on, it's going back down. It's decreasing.